Hi guys, so today we're going to be introducing what an inequality is. Okay, so far we've concentrated on solving equations. So remember, when we're solving an equation, all it consisted of was finding the values, which numbers for our variable made the two expressions, both sides, equal. In other words, we wanted to know what number made the equation true when we plugged in, right? In the same way, we can also judge the truth value, whether something is true or false, of a statement that is in the form of an inequality. Okay, so the difference is that instead of an equal sign, we will either have a less than sign or a greater than sign. Okay, so this is the definition of an inequality. If we compare any two numbers, let's say A and B, we will say that A is greater than B is true as long as A lies to the right of B on the number line, right? So here, if we had a number line, this would be true as long as A is here on the right towards positive infinity and B was closer to the left towards negative infinity. Okay? So here, given this equality, we're going to determine if it is true or false for the following values. Okay? So here, x equals 10. I'm going to plug in the 10 wherever I see x. Okay? So 3 here, parentheses 10 minus 2, greater than or equal to 2 times 10 plus 1. So all I did is, since x equals 10, wherever I saw x, I'm going to plug it in to see if it's true. Okay? After that, we're following order of operations. So in parentheses, 10 minus 2 is 8. Okay? Then next is multiplication and division. So 3 times 8 is 24. 2 times 10 is 20. Okay? And then last part is that addition. Okay? So 20 plus 1 is 21. Is 24 greater than or equal to 21? Yes, that is true. So that means x equals 10 is a solution to this inequality. Okay, I'm going to have you do the next one. Is x equals 5 a solution to the inequality? Okay, when you plugged it in, you ended up with 9 is greater than or equal to 11. That is not true, so this is false. 5 is not part of my solution set. Okay, so try this one next. Okay, when you plugged in 1, you ended up with negative 3 is greater than or equal to 3. This is false, so again, x equals 1 would not be a solution. Okay. So I'm going to have you try this last one. Is x equals 7, would it be true as a solution? Okay, when you plugged it in, you should have gotten 15 is greater than or equal to 15. That is true, so x equals 7 would be part of our solution, right? So notice that unlike equations where we had one answer, inequalities tend to have many values that make them true, right? For example, both 10 and 7, when I plugged it in, made the inequality true, right? And just as we solve linear equations by using properties of expressions and equations, right? Adding things to both sides, subtracting things to both sides, we can do the same for inequalities. However, we have to make sure we know that what those properties are. So let's test them, right? So let's consider the true equality. 4 is less than 8. Okay? So let's do that. So 4 is less than 8. Okay? So let's say if we add 3 to both sides, we want to know what the resulting inequality is. So I'm going to add 3 to both sides. 4 plus 3 is 7. And then less than. 8 plus 3 is 11. 7 less than 11. Is this true? Yes, this is true. 7 is less than 11. Okay? So what about the next one? If we subtract 4 from both sides of the inequality, what is the resulting inequality? So we're starting with 4 less than 8. This time, though, we're going to subtract 4 from both sides and see what happens. Okay? 4 minus 4 is 0. Then we have less than. 8 minus 4 is 4. Is 0 less than 4? Yes, that is true. Okay? So let's try another one. So let's flip here. Okay. So can you try this one on your own? With 4 less than 8, this time I want you to multiply both sides of the inequality by 2. I want to know what the resulting inequality is. Is it true? Okay, you should have gotten 8 less than 16, and that is true. Okay, so far addition, subtraction, multiplication works. Let's see if we divide both sides of the inequality by 2. What is the resulting inequality, and is it true? When we divide both sides by 2, we end up with 2 less than 4, and that is true as well. Okay, so based on what we did, whether we added, subtracted, multiplied, or divided, as long as we did it to both sides, it seems that our inequality stays true. However, this is very important. I want you to highlight it. There is one huge difference between inequalities and our equations. And we're going to try it with the next example. Okay, so again, we're going to use 4 is less than 8. However, this time, what I want us to do is we are going to multiply by negative 2. Okay, so we're going to multiply by negative 2 on both sides. Negative 2 times 4 is negative 8. 8 times negative 2 is negative 16. Is negative 8 less than negative 16? This is false. The reason is if we see it on the number line, negative 8 would be here, right? 0 would be somewhere here. And negative 16 would be here, right? So again, this is towards positive infinity. This is towards negative infinity. So the numbers on the right are bigger, right? So negative 8 isn't less than 16. It is false. Negative 8 is bigger than negative 16. Okay? So let's try it. What if we divide it by a negative number? Okay, so we have 4 less than 8 again. This time, though, we're going to divide by negative 2. 4 divided by negative 2 is negative 2. 8 divided by negative 2 is negative 4. Okay? Is negative 2 less than negative 4? No, it is false, because again, if we have our number line, negative 2 is here, negative 4 is here. It is bigger, so this is false. And so what we see is for inequalities, okay, as long as we add and subtract, that is fine. As long as we multiply and divide, it should still be equal. However, if it is a negative number, what we end up doing is we need to flip that inequality sign, right? So I'm going to write a note to myself. When we multiply or divide by a negative number, we need to flip the inequality sign. Okay. So hopefully that gives you an introduction to inequalities. I hope you have a great rest of the day. Bye, guys.